I'm going to have another coding session on the internet, and this one's about monocular 3D, and it should work for a robot as well. So it works as follows. If I've got so much RGB video and I've got one frame of the depth map, I should be able to match from the rest of the frames to the one depth map, and it doesn't tell me the depth exactly, but it gives me the normalization factor for discovering the new depth on the new picture, and it works via screen texture. It's poorly explained, but as I continue on through, you might get what I'm doing a bit later on. The cool thing is it could work for a robot, so like, because I can gather depths, like 3D positions, and therefore depths of when the robot hits against things. Like it can get the floor, and then it can bump against the wall, and it can even touch a person, and it can get this normalization factor which lets it produce depths. So it works for a robot too. And the cool thing is, if you want to make 3D aliens or something, you want to go steal the stuff from aliens, you just got to mock up, like say 10 or so depth maps by hand, and it's possible to do. It's not too impractical, and then it should discover the rest of the depths off like matching to those depth maps. So it doesn't actually just get the depth, okay? But I know a technique using the screen density, the textural density. Okay, I'll try and explain it. So if I've got an image, if I get a window and then just sum up the Sobel map, the Sobel map is like the difference on the X and Y, that gives me the textural density. Like, and then when there's it's a blurred Sobel map, so like you get the Sobel and then you blur it, and then I get that as little windows, and then I add it up, and then I just say that's the 3D depth. So that is like the 3D depth, except there's a good correlation for the 3D depth as it changes, but it's like it's missing the normalized amount of detail that was supposed to be there for it to be at X away. So if I start off with a depth map, that gives me that extra value I need to turn it into a depth value. So are you saying to me, as this blurred Sobel map moves forward and backward, it's actually moving forward and backward correctly as if it was supposed to do that in the 3D, except the problem is it hasn't got the starting position for the depth. So if I started off from a depth map, then it should continue on from the depth map from there, just using the textural density. So I have to see if I'm right. Anyway, I don't know if you understood me, but that's how I'm doing it. And first thing I'm going to do is go to this Connect video on the internet, and I'm going to collect about 10 or so depth maps from it, match it with the RGB, and then this will give me the peg-off positions for the textural density to take over to approximate the 3D movements. Yeah, so it gives me the starting location. Like, it's kind of like, it is 3D, it's just that it hasn't got the starting position for where the 3D started. So bad explanation. Or maybe you understood me, but I'm doing that. That's going to be the next video set I'm doing now, and I'll see if it works. It should be pretty cool, and it does work for a robot with one RGB eye, full 3D.